All right, let's get right into it. Welcome to today's Explainer, where we're taking a completely comprehensive 360-degree, bottom-up look at the modern AI tech stack. We're pulling all of this directly from the latest insights in the Next in AI newsletter. Now, if you're an investor, an executive, or a builder trying to track the bleeding edge of this stuff, you already know things are moving at absolutely breakneck speed. So our goal here is to cut through the noise, pull out the most impactful news, and map out exactly how this infrastructure is actually being built, deployed, and governed.
Let's actually anchor this whole explainer on a core premise from the newsletter. The quote here perfectly captures why these developments should matter directly to your portfolios and your strategic roadmaps. You see, we really aren't just looking at isolated tech breakthroughs anymore. We're watching a live, incredibly complex interplay. It's a dynamic where massive capital investment fuels technical innovation, which then immediately forces us to wrestle with the societal fallout. To understand one piece, we have to understand all three.
So here is our roadmap for today. We're moving straight up the tech stack. First, AI infrastructure and compute. Then, enterprise AI in action. Third, we'll look at the frontiers of applied research, and we'll wrap up with hidden costs and governance. Okay, Section 1, AI infrastructure and compute. Let's start right down at the bedrock that powers this entire ecosystem. Just take a second and look at this number, 512,000. That is the massive token context window of DeepSeek-V4 Pro, which just became available on TogetherAI. And honestly, this number just showcases the sheer mind-boggling scale of modern infrastructure. I mean, 500,000 tokens? That means an AI model can hold entire sprawling codebases, massive financial documents, and huge research syntheses in its active memory all at exactly the same time. This is a total game changer for what AI agents can reason through without losing the plot. Now, what's really fascinating here is the massive tension developing across the industry. On one hand, you've got OpenAI aggressively scaling their massive Stargate initiative, right? They're building out crazy data center capacity specifically for AGI demand. And then you have Stanford's Human-Centered AI Institute pumping over $2 million into scaling research. But then, look at that last point. Hugging Face is out here waving a giant red flag. They're warning that evaluating these giant AI models is becoming the new compute bottleneck. We are scaling hardware so incredibly fast just to build the models that simply testing them to see if they actually work is choking our compute resources. So how do we fix that? Well, the crucial point for investors and technologies here is the hardware evolution required to break that bottleneck. Standard AI chips are practically hitting a brick wall when it comes to memory. Enter 3D stacked AI chips. These use a distributed architecture called voxel. By using advanced packaging with high-density through-silicon vias, or TSVs for short, they literally stack DRAM memory directly on top of the AI processing cores. It's like stacking pancakes. This entirely bypasses standard memory bottlenecks and creates the ultra-high bandwidth we need for the next generation of large language model inference.
Moving right along to Section 2, Enterprise AI in Action. Let's see how legacy titans and nimble startups are actually putting all this massive compute to work.
These are the heavy hitters proving that AI is way past the academic research phase. It's actively reshaping the enterprise right now. Vanguard, the global investment giant, is fundamentally restructuring their data architecture with AWS. They're making it AI-ready to power their virtual analyst. Meanwhile, on the productivity side, Google is integrating file generation directly into Gemini. What we're seeing here is a massive shift. We're moving from AI as a fun chatbot to AI as a core data utility. And that points to a massive unlocking of capital efficiency for operations at scale.
But let's look at Bloomberg's Ask B agent because it serves as a perfect reality check for enterprise deployment. Bloomberg built a highly potent new AI agent. Their main takeaway from the whole process? Well, building a financial AI agent has incredibly high potential, sure, but deploying it securely, reliably, and accurately within legacy constraints is an absolute nightmare of a hurdle. It is immensely difficult to get right, especially when the stakes are global financial markets.
But those challenges definitely aren't slowing down the deployments. We tracked some rapid-fire launches on Product Hunt, and they split into two really clear trends. On one side, you have AI as a personal operational shield. Think tools like MyAO and Mail2Doc. On the other side, you have AI for autonomous quality assurance, like Kusho AI and Spec27. Both tracks are aiming to prevent context switching for professionals, while drastically accelerating test environments for builders. It's just a massive push toward these highly specialized, hyper-functional micro tools.
All right, Section 3, Frontiers of Applied Research. Let's push a bit further into the future and explore where highly specialized applications are heading next. Take a look at Kara. This is an end-to-end AI karyotyping system designed specifically for clinical cytogenetic laboratories. Now, what makes this so special is how it operates within incredibly strict clinical constraints. It doesn't just use one massive generic model to do everything. Instead, it uses a microservice pipeline. First, a combo of EfficientNet B5 and UNet handles the semantic segmentation. Then, a mask-R CNN steps in for instance detection. And finally, a ResNet 18 model handles the classification. This proves that highly specialized medical AI absolutely requires a cascaded, highly orchestrated approach. One size fits all just doesn't work here. And the major theme emerging across the board here is an aggressive push toward physical integration and edge computing. Diamond Robotics just released an omnimodal dataset designed specifically to give robot hands a high-resolution sense of physical touch. Over in healthcare, VR is being used to build really fast automated patient-specific simulations for spine surgery. No more generic training scenarios. And in the automotive world, researchers are using knowledge distillation to cram complex object detection models onto highly constrained edge hardware, specifically operating under INT8 quantization just to keep vulnerable road users safe. We are literally forcing AI out of the cloud and into the messy physical world. Now, let's pivot to a fascinating case study that bridges research and maintenance. OpenAI recently published a timeline tracking down what they called goblin outputs in their models. Basically, these were strange personality-driven quirks just popping up in GPT-5's behavior. And this timeline perfectly illustrates the wild new reality of AI maintenance. You have the emergence of an issue, its rapid spread through the model, an intense investigation to find the root cause, and then applying systemic hotfixes out in the wild. It's honestly like performing open-heart surgery on a living, breathing system. Which brings us to our final section. Section 4, Hidden Costs and Governance. It's time to sober up the technological hype with a hard look at the human layer and systemic risks. So, the single most crucial point of this entire explainer might just be right here. Frank Janak introduces this, frankly, terrifying new concept, epistemological debt. Basically, when software engineers rely too heavily on large language models, they substitute their own logical derivation with passive AI verification. And over time, this creates a cognitive systemic collapse. The developers literally lose the mental models required to perform root cause analysis when things inevitably break. They forget how the system actually works because, well, the AI has been doing all the thinking for them. And this cognitive gap extends way beyond software engineering. It goes directly into HR and operations. Think about recruiting workflows. Gen AI is explicitly designed and intended to just be an aid for human decision-making. But when researchers interviewed actual recruiters, they found a really stark reality. These professionals feel a distinct, pervasive loss of agency and control when they're working with these systems on high-stakes employment decisions. The psychological gap between an intended aid and a perceived replacement is vast, and it's causing real friction. We're also seeing AI directly threaten the credibility of academia. Enter HalluciChecker. This is a newly introduced toolkit specifically designed to detect and verify hallucinated citations in scientific papers. Because yes, AI assistants are increasingly generating totally fixed citations for research that simply does not exist. To combat this degradation of scientific credibility, lightweight verification toolkits like this one are quickly becoming absolutely mandatory. The operational reality of maintaining our broader software ecosystem is also shifting dramatically. Researchers analyzed over 61,000 GitHub repositories and found that hotfixing in the wild is totally changing. Thanks to the rise of autonomous coding agents, human-led fixes are becoming much smaller, much more urgent, and they're increasingly being pushed by single contributors with way less collaboration. We are essentially building isolated high-pressure workflows just to keep the lights on. And that brings us to the Zig project. They are a programming language community that recently instituted an outright ban on AI contributions, just to protect the integrity of their code. So, we want to leave you with this final provocative thought today. As compute infrastructure scales exponentially, and as these models are deployed into everything from finance to actual spine surgery, are we building the right guardrails? How will your organization manage the epistemological debt of the intelligence age? Thank you so much for joining us for this explainer. Dig into the sources, consider the architecture, and we'll see you next time as we continue to unpack the frontier of technology.